Okay, so we have our tornado tracks clipped by our state of Illinois here, and we have our hex bins that we've made clipped by the state of Illinois. Okay, and so what we want to do is figure out a way to aggregate these tornado tracks so that each hex bin registers the amount of tornado tracks that intersect with it. So for instance, right, this hex bin here would have 0, this one would have 1, this one would have 5 or whatever number that is. So we want to capture that value, but we also want to capture the magnitude of each of these events, right? Because tornadoes, not all tornadoes have the same intensity, the same on-ground impact, right? And so if we have one high magnitude event here, for instance, that might be more impactful than, say, 5 low magnitude events down here. So what we want to do is capture both those variables. And I'll show you the data a little bit so you can get a sense of what the variability of the magnitude is. Right, and so magnitude of tornadoes ranges from a 1 to 5 scale. So if we change this to graduated colors, let's change the field to magnitude. There's a -9 value, which just basically means not registered. So we can, let's just crank this up to 7, that's fine. Just so we can see here between this orange values, which are low magnitude events, ranging up to red, which are high magnitude events, right? So for each of these hex bins, we want to count the total number of tornadoes and the intensity, the sum intensity of the tornadoes. Okay, so here's how we do this. First, we go to our toolbox. We'll go to spatial join. We want our target feature to be each of these different hex bins. We want our join feature to be the tornado tracks clipped to the state. We'll give it a name. Let's call this Illinois. Okay. 1-to-1 is good. Intersect is good. There's a whole bunch of different options here of ways that you can tell the input and the target, or the target and the join feature relationship, right? Completely within, have a center within, contains. Intersect is fine for what we're doing. And then we go to our fields. Let's go down to magnitude and go to this edit tab. And so what we want in magnitude is not the first instance that it comes across, but rather the sum. So this is going to give us the total value of magnitudes that exist in each of these hex bins. So for this one down here, for instance, right, we have one high magnitude event, one medium, a couple small. The total magnitude of those events might be 15 or something, right? Whereas this one here, it has one medium event, right? So the count on this one will be 1. The magnitude will be the sum of just that one variable. Okay, so go ahead and hit OK here. That's good in our fields. Everything else is good. Let's just go ahead and run this thing. Okay. Close this out. Now, if we open up our Illinois Hexbin tornado field or attribute table, we can see now that it has all of this data associated with it. Where before, if we looked at just the Illinois Hexbins, right, it just had the polygon boundary and the grid ID and the shape, which were all the same. So now we've attached, or we've joined this data to these hexbins. And now we can start visualizing these in a way that is interesting. So let's open up this real quick. Let's kind of go through. Right, we can see some of these hex bins have up to 19 tornadoes that have passed through them. Right, here are some of our high instances. And then, if we go to magnitude, Right, we can see that this one, for instance, up here, this has had 16 tornadoes pass through this bin here for a total magnitude of 23. Right, so there's both high frequency and high intensity in this area. Whereas if we go to, let's grab, you can see all the ones that have 0 count just are null, which is fine. Let's go to like this one, 7 events, for instance, and you see that these have varying magnitudes here. Okay, so that's how we do the spatial join and connect all of this attribute data here to these Hexbins here.